Hear me? Savita is also able to hear me? Good, good. So I've started the recording. Kurupa is also. So, all right, all right. And so where were we? We were at that. So we discussed about Bloom filters. All right. And then, all right. So, yeah, all right. Just a second. So, where actually were we? We had discussed about Zookeeper. All right. Today we were about to get started with Flume, Scoop, and Uzi. All right. Let me open the corresponding. All right. Before we start any of these tools, do you have any questions for me? Yeah, I think yeah, you are right. There are few. I think yes, you are correct. We had discussed up to. So I think where were we? We were on session number 9. We had discussed up to not this one, not this one. Yeah, yeah, this is the one. So all right. Actually, there are two sessions running almost parallel, morning and evening. So all right, I think we were talking about. All right, all right. So we were at watch triggers. Good, good. All right. So all right, so we are effectively running around 7.5 minutes late, and that we'll have to, compensate afterwards. All right. So before we start with, we continue with Zookeeper. Do you have any questions for me? So a quick one. Zookeeper is like a big, provides you an interface like a big tree in which you can create nodes, you can update nodes. Each node is the data storage. On each node, when you're creating node, you can specify that this is my data and this is the name of the node, and this is my data, and is the children of that particular node. So those kind of information we can specify, and there are three kinds of nodes. One is normal node, when you're creating a Z node, as in the way you create a folder, in the same way you can create a node in Zookeeper. All right. So, and these nodes, which are basically storage of data, they are quite, they have three kinds basically. One is normal one, second is sequential, and third one is your, what do you call, the the one which disappears. I forgot the name. The ephemeral node. Yeah, the ephemeral node. All right. And in general, you can just launch a zookeeper command line and get started with the zookeeper. Along with that, when you're creating nodes, you can start getting the notification also. You can create the events that if there are some children created for a node, inform me, as well as you can have various kinds of notifications. And how do you create notifications? Whenever you are executing a command such as exist, get me the data, get me the children of a particular node, while you are executing any of these commands like ls or anything, you can specify your watch trigger. And the watch trigger of the command called exist, so when you are saying, when you are trying to check whether a particular node exists in zookeeper or not, you can specify various kinds of triggers, such as give me the notification when this node gets created, deleted, or data gets updated. Also, while getting the data of the node, you can get informed when the G node gets deleted or its data gets updated, and you will get notification of get children whenever you are, when you create a watch trigger of get children, you will get notification for if the node gets deleted or it's any of the child gets modified or updated or deleted. All right. So, all right. So basically, we talked about two things: that there is a zookeeper in which we can create nodes. We can create various kinds of nodes, as well as we can also put the watches on each particular node. All right. So Anuj, I think, yeah, yeah. All right, all right. Okay, okay, okay. So yes, it can be moved. No worries. I'll discuss with you after this session. All right. I'll have a discussion with you after this session, and whatever is good for you, we will do that. No worries. All right. The only thing to all of you is, in case you are not getting the URL, try to use the old one, previous URL. Generally, URLs are not changing for the webinar. Second, try to check in the spam folder. It's generally there, and we are not able to figure out what is making our emails spam. All right. We are really not able to figure that out. All right. So we can have a discussion after this. All right. No worries. All right. Now we have, okay. So just like any other system, Zookeeper is also used by many systems in an organization. For example, let's say you have a Hadoop installation in your organization. So when HDFS and name nodes communicate, they use Zookeeper. Name node and data node communication requires Zookeeper when you are running in a high availability mode. Similarly, HBase and its node communicate to each other. The region servers and the HBase master, they contact each other and discover each other using Zookeeper. Similarly, Yarn also uses Zookeeper. There are many systems which rely on Zookeeper. And you can also write your applications which can utilize Zookeeper as a very small database for a very high concurrency and coordination. So which brings us to the point when there are so many different applications accessing the same database, different teams, different set of users. How do you ensure the how do you ensure that one user does not impact the other user's data? Therefore, there is something called ACL, Access Control List. It determines who can perform certain operations on it, depends on authentication. Basically, access control in any software has two parts. First is called authentication, other is called authorization. Authentication means, anyone? What does it mean by authentication? So Anuj, don't need to drop off. Do not worry about, because I am very sure that things are very simple in nature. Okay, you don't need to drop off right now. You try to follow up. Okay, and then we try to see that. Okay, no need to. I mean, do not worry that you'll not be able to handle it. Okay, I try to be little bit more repetitive in talking, so that in case you missed out my previous sentence, you can catch it up. All right. Yeah. So Damodaran says regarding the authentication that it's legitimacy of the user. That is correct. And what about the authorization? How do you differentiate between what is authentication and what is authorization? Anyone else? Correct. Authorization means provide access to the user and privilege. Good, good. Thank you, Damodaran. Anybody else? Yes. Anuj says authentication is more security related and authorization is good, good, excellent. All right, all right. So just like any other system, the way your MySQL has users and roles, similarly, because it's a Zookeeper is nothing but a sort of a database in which there are nodes. You store the data like a tree, and we cannot say it database per se. It's like a data store. It's like a big tree in which you are creating nodes, and each node is storing data. Okay, so it also provides authentication and authorization. Authentication means what is your login ID, and making sure that you know you are that login which you are claiming, either by the way of password or by the way of other things. When it's based on password, when I'm making sure that you are Anuj because you know the password of Anuj, okay, that is called a digest. Okay, I mean, that is called digest way of making sure the authentication is correct. Second is SASL. In this case is called Kerberos. What does it mean? It means that you logged in into the network once, and some service called Kerberos made sure already that you are Anuj. And we are just asking Kerberos that this guy is saying that he's Anuj. Is he really Anuj? And that is done based on certain token, so that this user doesn't have to keep logging again and again, and instead Kerberos makes sure that there is a single sign on. Okay. Third is the IP based. In the situations where IPs can be trusted, specifically in certain security environment, in certain data centers, IPs are very hard bound with the MAC address. And when you bind a IP address with a MAC address, in those cases, it makes sense to depend the authentication based on IP address. But again, IP address is not a great way of ensuring the security. And these things are true for almost all other softwares as well. And out of these three, SASL is probably the most convenient one for the user, but it's little difficult to configure initially. Okay. Next is the access control list. Once a user is authorized, we made sure that this person is Anuj by the way of various means. Now, what is Anuj allowed to do? That is authorization. Okay. So, access control list has authentication scheme. First, making sure that Anuj is really Anuj. Second, what are the permissions allowed for that user? Is Anuj allowed to delete this node? Is Anuj allowed to update this node? And so on. That is part of the permissions. Okay. So Zookeeper gives you all that control to manipulate the nodes, giving the permissions and so on. Alright. Similarly, Zookeeper Zookeeper also provide you various modes of authentication. Next is architecture. So Zookeeper runs in two modes. One is called standalone, other is replicated. Standalone is like you download a virtual machine, run the Zookeeper, everybody is happy, there is a single node, nothing much. So Zookeeper does not make sense to run it on a single node. Why? Because what if one node goes down? Then none of the services depending on Zookeeper will be able to use Zookeeper. So far, we always talked about this folder structure and all of that. But internally, Zookeeper is running on multiple machines simultaneously. And why? Because because in case one node of Zookeeper goes down, the data will still be available. The end user, our Zookeeper client, this Zookeeper client which we talked earlier, I think I'll just run terminal. In case you guys want to run, you can run in the browser, but I'll be running in the terminal because it's easier for me to switch between the windows. So let me just SSH student. All right. So here is Zookeeper client. All right. Now in this, so when I'm connected, I'm the client. I do not need to know that how many machines are running, or I do not need to know which one to connect to. Zookeeper automatically, the client automatically connects. We'll talk about it in details, but this mode in which we run multiple instances of Zookeeper is called replicated. Single mode you only run for testing and you for the hello world kind of application. In case of production, you always run a replicated. Okay, so Zookeeper runs on a cluster of machines. We call them ensemble, and they are highly available, and it tolerates as long as there is a majority. So again, if Zookeeper is running parallelly on a 10 machines, those 10 machines is called ensemble. Zookeeper will tolerate as long as 6 out of 10 machines, 6 out of 10 machines are alive. That means it tolerates as long as there is a majority. Okay. So if you are running Zookeeper on 10 machines parallelly, it will tolerate as long as there is a majority. Good. All right. So Arvind has a one more point confirming whether user is real user or not programming user. Example is captcha in many websites. Okay, that is not part of authentication. That is like one layer above the authentication. All right. So making sure user is really user, whether it's API, whether it's an agent, or whether it's a real user. That's all of these three cases come under authentication. All right. Okay, now coming back to the architecture again, let's understand what is exactly going on. So, so as I told you that there is an ensemble, there is a ensemble of zookeeper, meaning you have designated 10 machines for just zookeeper, or you already have data nodes running on 10 machines and you thought, okay, let's just put zookeeper on all of them. Okay, that you can do easily. So but it will be like too much, asking too much from the machines. So you establish an ensemble. Now what will happen is the first phase, when you turn these machines on, there'll be a leader selection procedure. Why do we need leader selection? Because there has to be only one machine out of all these 10 machines which will accept the write request. Write means you want to change some data, delete some node, edit some node. So all of the modification requests go to the some one particular node called leader. Unlike our name node and data node, unlike our yarn, where in case of yarn or Hadoop, we always designated ourselves. Our sysadmin will designate that this node is called data node and this node is called name node. But in case of our zookeeper, we don't do that. Zookeeper, the ensemble, the 10 machines will decide by itself who will become leader and who will become the followers. All right. Okay, so coming, some of you must be wondering, why do we want to discuss all of this when it only relates to Zookeeper and Zookeeper is tangentially related to Hadoop? Why? Because the architecture of Zookeeper is central to the idea of parallel computing or distributed computing. If you take case of Cassandra, MongoDB, and other systems, they all depend upon the same architecture, and this architecture is called Paxos algorithms. Okay, so all of these systems, be it MongoDB, be it CouchDB, all of they share the same architecture. They have an ensemble of machines. One of them is selected as leader, and that leader takes all the modification requests. Whenever I from this, so whenever I have so here, if you see this, so if I'm saying get request, it will not necessarily go to the leader, but set means I'm trying to modify the data. If I say set this path with this data, means that I'm trying to modify some data on the nodes, and those requests go to the leader. And why is it so? Such that the data does not get corrupted. If there are multiple leaders, multiple people accepting the modification request from the client, then what will happen is it will be very difficult to make sure the consistency of the data. Imagine you are trying to modify a node, I have deleted that node. What will happen to the modification you just did? Or you are trying to increase a number by 1 and I'm also trying to increase a number by 1. Now both of us are trying to modify the same thing. You might end up with the race condition which we discussed earlier. Okay, therefore there has to be a single leader. So out of the full herd, full ensemble, there has to be a single leader. Okay, all other machines are called followers, And this, as soon as ensemble comes up, they elect a leader. They vote for each other based on how responsive is the leader. So each one is voting for each other. Whosoever gets the maximum votes based on the ping time response. So the voting is based on individual nodes' behavior towards the leader, because every node will ping each other node and note down how much time it took to respond, and then give the vote accordingly. And that is how the leader is selected. Now, as soon as the leader comes up, every node will sync their state with the leader. And in case at any moment of time leader fails to perform, in case leader fails completely, the remaining machines will hold the elections, and the elections generally take again 200 milliseconds. So the moment leader fails to perform and there is no leader for some time, leader is not responding to the ping request, there will be re-election and somebody else will be made the leader. So now you can see that there in the cases where the leader has failed, there will be a there will be no leader for 200 milliseconds, and therefore there will be a glitch of writing requests for 200 milliseconds. All right, so is leader election clear to everyone? Feel free to ask if you have any questions. This is very important because this is going to help you when you look at the architecture of MongoDB, you look at the architecture of other distributed systems. Okay, till now you only saw the master slave kind of architectures. This is a newer architecture. So is the leader election or leader selection, whatever you want to call it, is clear to you? Okay, so Arvind is saying how heartbeats are measured. So each node is sending heartbeat to each other and notes down the ping time, how much time it took for the node to give the response. And then based on that, based on the time and number of packets lost, it will form the opinion of other nodes. Okay, Damodaran says that seems similar to OSPF designed designated router election. Yes, that's correct. So this lies under algorithm called Paxos. It's a little complicated. I'm trying to simplify it. So Damodaran says, is the leader selection happen every time node get deleted or added? Okay, brilliant question. So can anybody answer it? Yeah, I'm trying to see what is your guess. Anyone? This one? There is another question from Arvind. I'll just note it here. So, all right. So no. Okay. Urs says no. I agree with that. And that's the thing. So the leader selection does not happen every time a node get deleted or added, because in case you are deleting a leader itself, the leader selection will not happen. Okay. If you are deleting the leader itself, then it will happen. Or okay. So there are two scenarios. So in case of addition, no. All right. Second, in case of deletion, if deleting the leader, then yes. If uh, yeah, if deleting is resulting in minority, as in there were 6 nodes out of 10, 4 nodes are already dead, and you stop one node. Now there'll be only 5 nodes left, which means there are minority left, and therefore, uh, I mean, therefore, there will be no election, but the leader will step down. Okay, good question. All right. Now, okay. Now, continuing with otherwise, what will happen is else. Okay. So in case this we are deleting a leader itself, then somebody else will become the leader based on the new election. So elections will be announced if the leader is dead, or we are deleting the leader. Okay. But in case of addition, there will be no election unless the current leader fails to perform within a stipulated time. Okay, if the leader does not respond for 200 for some time, I'm not sure if it is 200 millisecond. If leader fails to perform, suddenly leader will be step down and election will be announced. Okay, therefore, otherwise the leader will continue to whosoever it is. All right, good, good. Now Damodaran's question is further follow-up question. I'll come to Arvind's question later. What if the node that gets added is having better, still, still the current leader will continue. Okay, current leader will continue. All right. Okay, even if the newer node is really powerful and very good, still the current leader will continue. Otherwise, what you can do in these scenarios, you can force the current leader to stop, and then suddenly the newer node will become the leader. But there is no guarantee that your more powerful node will become the leader. All right. So also that brings us to a point that in a zookeeper cluster, it does not make sense. It does not make sense to have one node very powerful and rest very weak. Okay. Because it doesn't give you any added advantage. Alright, now next question from Arvind is, so every node maintains opinion about the other nodes. That's correct. Whenever an election happens, they gather the opinions and then they vote for each other. Alright, now next is what happens after somebody becomes leader. When somebody becomes a leader, that means now our zookeeper cluster can accept the rights, accept the changes from the user. Whenever a user is trying to set, delete, update, or say create node, those all requests will be forwarded to the node who is leader. Even if our client is connected to somebody who is a follower, the request will all be forwarded to the leader. Okay. Now the leader broadcasts the update to the followers, and when a majority has persisted the change, the leader commits the update. Okay? When the majority has persisted the change, the leader commits the update. The client gets success response. The protocol for achieving consensus is atomic, like two-phase commits. Okay, machines now. Okay, so is I hope you are clear about what does it mean by all write requests of being forwarded. The next diagram will show you this. Okay, so what's happening is there are so many clients connected to our ensemble. This is our ensemble. It has got three machines. One is leader and these two are follower. If client is trying to read, then the read might happen from the follower. But if the client is trying to write, this follower will forward the request to the leader and tell the client to directly talk to the leader and not bother him. Okay, so that's what it is. And when the majority have persisted the change, then the leader will commit the update and client gets the success response. Okay, majority has persisted the change. So what does it mean? What will happen is the client tried to write something, it was forwarded to the leader. Leader will send the new changes to all the followers. If there are 50 followers, it will send the changes to all the 50 followers. Okay, and those 50 followers will accept the change, and after they have accepted the change, as soon as the leader gets a confirmation from 50% of the nodes or majority of the nodes, including leader itself, it will give the confirmation to the client that your changes are safe with us. You can be assured. All right. That's how it happens. So write is also majority based. It's not all the nodes. Okay. Now that brings us to another point, that all of the node will consume equal amount of data, which means if you're trying to store 1 MB, that 1 MB will be stored on all the nodes. Your data is there on all the nodes. Okay, and that effectively make sure that the reads are really powerful and really fast, because reads can happen from any of the followers, but write will only happen from one. So now, okay, so what does persistent means? Means saved, when you saved to the disk. Okay, let me change the keyword here itself. When majority has saved the change. Okay, saved or persisted, saved into the disk basically. So if you notice one thing, if you have got if you have got 100 nodes and you are trying to store 2 MB data or 20 MB data, how much actual space is being used? Anyone? So if you have 100 nodes in your ensemble and you are trying to store 20 MB data, after some time when the change get persisted, finally after eventually, how much storage will be consumed because of this change? 20 MB into 100, which is 22 GB storage. That's correct, Shisha. Shisha, it's, I think you mean to say 2 GB, not KB. All right. All right. So good. Because this 20 MB data will go to all the nodes, and that also means really fast access, but but not good, not good for anyone. What is what it is not suitable for this database, this zookeeper? Correct. It's not suitable for writes, and it's not suitable for storing big data. If you have to, that's correct, Santosh. If you have to store big data with TB of data, it's not good. Okay, it's not good for storing huge data. So don't consider it like a database. Instead, consider it just to store a temporary amount of data. Yes. So Damodran, this 2 GB is basically 100 copies of this 20 MB data. Okay, because there are 100 nodes. All right. I hope that makes it clear. Okay, so this replication here in case of Zookeeper is 100 times, but that is not the case with MongoDB and all. We generally mark that these are the replicas, and you can only have at most 3 replicas or 4 replicas. Okay, here this like equal number of nodes have these replicas. All right. Now coming back to the question here. All right. So when reaching to a consensus, okay, whenever we are trying to write the data, we have similarly whenever persisting the change, whenever we are saving the change is like making sure there is everything is saved successfully. Okay, and since the saving is like atomic mechanism, or saving to a node is a atomic mechanism, you can consider it like as if it's a commit. Also, the one interesting fact about Zookeeper is the machines write to the disk before memory. Therefore, what does it mean? It means the writes are a little bit slower because it has to make sure the majority has persisted. Therefore, writes are slower, but there is a guarantee of consistency. Okay? All right. So this architecture is clear to everyone. I'm hoping that. These are very interesting architectures. You should keep that in mind. We studied the name node and data node kind of architecture where we designated the nodes. Here, Zookeeper is automatically designating, intelligently, automatically designating leaders and making sure there is an availability. These kind of systems have been really, really powerful in the case of distributed computing, so that using these systems you can make your software really available, highly available. Okay, and those nodes which those systems where whichever require coordination, they can use Zookeeper reliably. Damodaran's question is, what is the difference between follow? Client are the users like me and you, like this command line. Okay, this is the client who is interacting with the Zookeeper. I'm saying give me all the nodes who are children of slash. Slash is the root node. That's what we have said. ls slash. Okay. And if I want to say give me the list of fab 28, there is a fab 28 node, and I can say that. All right. I can get the data. What is stored in case of fab 28. You can see Mark, Sarju, and Anand is the data. Perfect. So I am the client right now. This command line is the client. Okay. While follower and leader are part of the ensemble server. These are part of the server. For the user, this whole thing, all of these system will look like a single machine. The way I'm feeling as if I'm talking to a single machine right now, the way I do ls locally, that's what I'm doing. But internally, Zookeeper would have multiple machines running parallelly. Okay, you might be talking to any of the followers or any of the leaders based on whether you are reading or writing. All right. Make sense to you? No? All right. Okay, then for some reason, where did my question window go? Window, bring all to the front. So can you ask a question? Can somebody ask a question? I can't see the questions window. I need to see where did it go. I found it, I think. I think it is somewhere. Let me try to. So let me again try something. I think that should work. Here, I got it. This is irritating. How do I change it? Good, good. I think I got it. All right. All right. So if I open my questions window, yeah, good. Awesome. All right. So actually, it has gone to the next desktop, and I'm not a big fan of these desktops. Sorry for the whole fiasco. All right. We have a good question from Arvind. He says that how many TPS it can process. So as I was telling you in the beginning, there was a number that it has been tested to give really high throughput. It has been tested to really give very high throughput, and the throughput was around, see, 10,000 operations per second. Okay, and per second for write dominated, while for read dominated it was far far above this one. Okay, good. So the protocol is clear to everyone. Now, coming back to this zookeeper surveys, so there was this election thing we talked about. Lots of us would be wondering, why do we require majority to do the selection of the leader? If at any point of time during election majority of the nodes are not available to participate in election, then leader cannot be elected. If you have 10 nodes, if you have 10 nodes total, when you started your cluster there were 10 nodes, but right now there are only 5 nodes available to participate in the selection of the leader. Only 5 nodes are available, then there will be no leader unless there is a majority, unless the majority of the nodes are available, meaning 6, 7, 8, 9, 10. There will, I mean, there will be no election. If there is a minority, meaning 5, 4, 3, 2, there will be no election. Okay, the leader can be selected by the majority only. So that means, let's say you are running a cluster of 10 nodes, and what happened was 4 node went down. Still, there will be an election and there will be a leader. If the leader is not dead, there will be no effect on the cluster. Now, the moment sixth node goes down, there will be if it's leader, then anyway there will be no re-election. If one node which is not leader has gone down, the leader will step down and there will be no leader. Effectively, what I'm trying to say is, the moment out of 5, if 50% nodes are not available, there will be no leader. Okay. Arvind's question is there a limitation on the data size in the node? I think there is a limitation. I need to check exactly what limitation is there. Okay, but there is a limitation on the data. Okay. Now, Srisha's question is, if there is no leader, then who writes? My answer is that no one. In case there is no leader, there are no writes, and the whole cluster becomes read-only. Now, that might sound very awkward to you, right? If you have ABC 3 nodes and A is dead, then who will become the leader? Anyone? There are 3 nodes A, B, and C. A is dead. Correct. So, thank you, Urs. B or C will become the leader. That's correct. So, B or C will become the leader. Either B will become the leader or C will become the leader. All right. Is this clear to everyone? So, since there are 2 nodes still available out of 3, which means majority is still available, there will be a re-election and a node will be selected as a leader. All right. So, because there is a majority still. Now, what happens next? In case, let's say A was dead, C was elected as a leader. Now, if B goes down, what happens? So in our free case, let's say after A became dead, we elected C as the leader. Now there are 2 nodes, B and C. C is the leader. If B is dead, what will happen now? Will C remain the leader, or will C step down? Anyone? No. In this case, C will step down. Why? Because C will step down and no one will be the leader. Why? Because C doesn't have the majority. Nobody, I mean, there are only one vote out of three votes. There are only one node available out of three nodes. That means majority is not available. Majority is 2, because half of 3 is 1.5, and more than 1.5 is 2. Therefore, majority is not available for C. Therefore, C will step down. Okay. Now, you would be wondering that although we have one machine up, still we are not making somebody as leader. Instead, we are choosing for read-only cluster, meaning making nobody as leader means read-only cluster. Why is it so? Can somebody guess? Why do we require majority for the selection of the leader? Anyone? Is this clear? What does it mean by majority? Okay, let me ask again. I think this will make more sense. If you have 5 nodes in ensemble, how many nodes need to be alive for leader selection? Anuj? All right. Almost everybody is correct. So at least, at least three, at least three, at least three, not at least two, at least three, because three is majority, two is a minority. Okay. So as long as in our cluster there are three nodes which are really available, okay, nodes from 15th August, 15th August, 15th August 2015. Is everybody okay with this? Yeah. All right. So yes. Now let me understand. Does anybody have a? Do you know the reason why we require at least 3 out of 5? Anyone? My question is why? All right, we have a brilliant answer. If the nodes are geographically separated and their connection dies, both could opt out of sync. Brilliant, brilliant. Probably for the first time somebody has answered. Probably somebody has answered it. Uh, you know, I'll try to describe it again. You will graphically. Imagine this. There are two data centers, data center 1 and data center 2. Let's say there are in each data center there are 3 nodes each, which means 6 nodes. All right. Now imagine this. This connection between the two data center is con- cut, as in there is a network down between the two data centers. Now what will happen if majority rule is not followed? If we did not follow that we require majority, what would happen? Data center 1 and data center 2 both will have their separate leaders, right? Because D got some votes from this side, A got 2 votes, and this one got 2 votes, and everybody's happy. Let's choose D as the leader, and here A as the leader. So our our network has been fragmented. There are two separate leaders accepting two separate changes from the clients. Some clients are connected to A, some clients are connected to D, and all of them are happily making the changes, which essentially means if you have two writers writing the same data, there are the whole data has been corrupted. Okay, make sense to you? Our client might come to write first time on A and the second time on D, because client maintains a list of all the nodes and then they keep on contacting them. Make sense to all of you? So Damodran is okay. So if there are multiple leaders, there is a major problem, right? To avoid the multiplication of leaders, it makes sense to have the majority rule. Meaning, now, if this node, when the connection has been disconnected between the two data center, this will have minority, this will have minority. Now imagine this. Had there been 4 nodes this side, 2 nodes this side, okay? Had D been this side, so A, B, C, and D would have been this side, E and F in the second data center. The leader would be on the left hand side. The second one will not have leader because there is the majority on the left hand side. Are you okay? Feel free to ask questions because this is a very important concept. It took me some time when in the beginning days when I tried to figure out why do we have majority. It took me some time to reach to this conclusion. Anuj, Arvind, Damodran, Srisha, Kal, Kirupa, Praveen, Santosh, Savita, Subbareddy, and Urs. Urs is anyway clear, I guess. So Zookeeper is saying, sorry, basically Zookeeper is branch office and head office big data connection manager. Sort of, yeah. Okay. Is this, okay. All right. Let me take you through this diagram again. Probably this will make clear. So I was talking about when you have 5 nodes, you require how many, at least how many nodes? 3 nodes, right? Now let me change the question a little bit. If you have 6 nodes, how many nodes you would require minimum? At least 4 nodes, right? right? At least 4 nodes. So what would happen is, the reason behind having the majority is, in case there is no majority, do not elect a node to be the right leader. Otherwise, Otherwise, there are chance of data corruption by means of having multiple leaders. If majority is not required for electing a leader, then in case there is a network disconnectivity between two data centers, each data center can choose their own leader, and effectively imagine the same node being modified in one leader here, as well as same node being modified in another, and effectively there is a data corruption. Yes, one greater than the half of the total number of nodes. That is correct, Santosh. And the reason behind having that is because there could be only one part of the cake. If you are cutting the cake and you are making sure that it's your birthday and you want the biggest piece of cake, you will say that I want little bigger than 50%. Okay, if you say that I want little bigger than the 50%, you will have the biggest cake possible. Okay, nobody else will have the bigger cake than bigger piece than your piece. Okay, meaning there can be only one piece which is bigger than 50%. Therefore, to make sure there is only one partition of the network which can do the election at a time, we just to make sure there could be only one partition of the network which can select a leader, or there could be meaning there could be making sure that there is only one leader in the network. We impose the rule that only the partition having maximum majority of the nodes can elect a leader. That means there'll be always one leader. Okay, is it clear to everyone? Should I move? Otherwise, if there is no majority rule, what will happen is, in case of partitioning, every every section of the network will elect their own leader, and effectively there will be multiple leaders having multiple data rights, and the full chaos would be there. All right. Okay. And an ensemble of 100 nodes can tolerate a shutdown of how many nodes? Anyone? Quickly. An ensemble of 10 nodes, not 100, sorry. 10 nodes can tolerate a shutdown of how many nodes? Correct. 4 nodes. And 100 nodes? Anybody? If had it been 100? Correct. 49. Awesome. So everybody is now clear. Santosh, it will be 49. Okay. It's not 60%, it's like 51%. All right. The integer part of it. One more than the half. Good. Good. Let's move on. All right. These are the guarantees we have already talked about. And there is something called a session in Zookeeper. So the moment we have connected right now, the way when we say this is a session. So when we start our client, it creates a session. Let me go through these steps, and these things will become very clear. Although these are a common phenomena, but there are few minor differences you will notice here. Out of this, first, the way, have you ever created a connection to the database? If you have, you would notice that whenever we created the connection to the database, there was always one single database. Here, here, the zookeeper has multiple machines from which our client can read and to which it can write. Now, this client maintains the list of all the nodes in the zookeeper. Okay, whether you give it or not, it will ask a follower, or it will ask a member of zookeeper service saying, can you tell me who all are the followers and the leader right now, and will gather that list. Out of this list, it will keep on trying to read or write or connect until it is successful or the list is exhausted. Server creates a new session for the client. Once it has successfully able to find a node which is up and running, it will create. So client, as soon as client connects to the server, server will also maintain a session on the server side. The way on the HTTP web server you have a session. Similarly, Zookeeper also maintain a session on the server side for each user who is connected. A session, every session on the server side on the Zookeeper has got a time period. That is how, based on this time period, it figures out that which sessions need to be deleted, and if a session is getting deleted, all the ephemeral node related to that session get deleted. Ephemeral node means those nodes which disappear in case the client who created those nodes disconnects. So if you have created a temporary node or ephemeral node, it will get deleted as soon as you log out, or as soon as your connection is disconnected. If there is a wire disconnection or anything, the ephemeral node will disconnect, will delete. Okay, so basically this is all handled by the session here. Okay, if the server hasn't received a request, it will expire. Therefore, the client keeps on pinging that, hey, I'm alive, don't delete my session. The way when you are on a banking website, you keep on changing the pages so that the banking website does not log out, log you out. In the similar manner, the client keeps on sending the pings, heartbeats to the zookeeper service saying, I'm here, don't delete my session. Okay, so it's you as a developer does not have to take care of sending the heartbeats. It is your client library which will take care of it. Now sessions are valid on switching to another server. When you are when you are switching to another server from one machine to another in an ensemble, the sessions will remain alive. even though even though this client is trying to do all sorts of magic for you, in case one node went down, it got connected to another and so on, your application will have to handle the circumstances like the election is happening or not, those kind of because let's say you made a write request, you want to create something, you want to delete something, you want to update something. In those cases, you have to take care of the scenarios that what if my ensemble is in the mode of election? There is no leader right now, the election is being held. So, even though most of the complications are absorbed by the client library, still, still you will have to also take care of it. You cannot remain ignorant of the fact that there will be elections, there will be disconnections and all. All right. So the same thing is described here. Next is that how do you utilize? Okay. Now Subba Reddy's question. Let me answer this one. Okay, okay. The question is, if a data center one has five nodes and data center two has two nodes, data center two has one node. Is it possible for okay? Is it possible to elect as a leader one node which is there in the data center two? Yes. Definitely. In case the data center 2, the pings, it is based on the ping, the heartbeat. In case the heartbeats are doing great between all these nodes, then data node from data center 2 can also be elected. But the probability of that happening is very low. Reason being, mostly if it's a network, all the nodes in the data center 1 will win. All right? Very good question. All right. Now, Srisha's question is, what does it mean by ephemeral node? Ephemeral node are those nodes, okay? Ephemeral nodes disappear when the connection is lost or closed. Say you are connected to the server and you created an ephemeral node. Now you exit from, or your connection is lost by network problem or something, then these nodes disappear automatically. Okay, those are called ephemeral nodes. There is a very important role provided by the ephemeral node. Ephemeral nodes basically represent a client's presence, meaning it's like an attendance sheet. It's like I can see in the list right now that there are 12 users logged in. Okay, in this window of attendees I can see that there are 12 users logged in right now. So this basically is like an ephemeral node. Each row in this window represent one of you. Okay, so these are like ephemeral nodes. The moment any of you disconnect, you will disappear from this list. In this webinar, I'm talking about webinar. In this, there are 12 lists, and in case any of you disconnect, you will disappear from here. Similar is the ephemeral node. Ephemeral nodes disappear if you disconnect from the server. Awesome. Okay, the same phenomena of ephemeral node is being used here. You will understand it. What does it mean? Let us say you have millions of users and hundreds of servers. On left hand side you have hundreds of servers, and on right hand side you have millions of users. Now these servers, let's say this is your e-commerce website running on these hundreds of servers, and millions of users are coming. Now which user connects to which machine? How does it know? These users these users will have to connect to one of these machines, each one of them. Now who decides, who keeps track of which node is up and which node is down? Okay, who decides that? One is that we put that logic in the thick client, telling that keep on iterating the list, keep on making sure which server is up, which is very inefficient. Okay, or we basically have to do that very aggressively and will overcrowd. Instead, these servers have created their names in the list in the zookeeper. So there is a zookeeper which is maintaining a list of all the servers which are alive. The way I am seeing all the attendees right now in this window, in the same way zookeeper is retaining a list of all the servers who are alive. In case these servers do not ping for say 5 seconds, zookeeper will assume that server to be dead and will remove it from the list. Okay, and therefore these users will not be able to discover the dead servers. So that is how it works. And the moment server comes up, they'll inform zookeeper. The zookeeper, the thin line, is what contains all of the logic, all of this ensemble and everything, such that these clients can discover which servers are up. All right. So this is for making sure, say there is name node and data node. There are thousands of data nodes. You have to make sure that data nodes are up and available. For that, you generally use Zookeeper as the middleman. As soon as the data node comes up, it informs Zookeeper by creating a ephemeral node saying, hey, I am up. Or the same mechanism is also described here. The client connects to the server and says that can you can you create a node called duck under servers list, and then another machine comes up and says, can you create cow under the servers list? Now whenever the user comes up and says, give me all the nodes under the server, it gives out saying duck and cow. Okay, now after some time, let's say duck is killed, this particular server is killed, and then the client comes up, can you give me the all the children nodes of slash server? It gives up only the cow. Okay, so this way the whole attendance list, this way the client does not need to keep on pinging the user and asking it. All right. All right, we have done this hands-on earlier. You should try to do it by yourself. That's an exercise. Try to create your own nodes, experiment with ephemeral nodes, try to update, delete the nodes, and see what happens in case you exit the session. Okay. So there are many use cases of zookeeper like system, but main one is coordination. What it is not good for. Okay. Okay, now let me just make one more slide for all of you. Not to use in number one, not to use in number one, to store big data. Okay, not to use for not to use to store big data. That is one way. Okay, so keep that in mind, because not every tool is meant for everything. It's very important to not look at things like a sales pitch, because when you look at the sales pitch, you will feel that every tool can do everything. Okay, so in case of zookeeper, it's not great for storing big data because the number of copies are equal to number of nodes. Great. So that was our discussion on Zookeeper. That completes our discussion Zookeeper. Zookeeper, although lots of people do not cover in case of Hadoop, but I feel strongly feel that Zookeeper is very important when we talk about distributed computing. All right. That's why I've taken my time to explain. All right. Any questions for me, or should we take a break here? Alright, let's take a break for 10 minutes. Back by, alright, let's be back by 10:09 p.m. IST. All right, I'm back. Should we start now? So I'm back. All right. So let's start with session number 9. So before I start with session number 9, do you have any questions for me? No questions? Okay. So here we are. So the first thing we are going to discuss in is Scoop. What exactly is Scoop? Scoop is an open source tool that can extract the data from structured data store such as MySQL or any other database. And it can push the data into Hadoop for further processing. It can also move data from database to HBase, and you can export data back to the data store. Okay, meaning using Scoop you can do following things. One is let me just mark it as Scoop. One is from, let's say, MySQL to HDFS as like CSV file or something, or MySQL to HBase. Third, MySQL to Hive, and so on. All right, and also vice versa, HDFS to MySQL, and so on. Now your question would be, what is so big deal about it? You could write your MapReduce program, and inside the MapReduce program, you could basically create a database connection, and as we go through the records, it will keep on pushing that data to the database through the database connectivity. Now anybody can do that if you see this, but Scoop is heavily specialized in this so that you don't have to write the code for importing and exporting data. You can continue to focus on your main business logic while the general importing from databases into Hadoop ecosystem can be easily done and quickly done through a very flexible command line of Scoop. Okay, so the command line of Scoop looks like this. So if you go to the command line, you can say Scoop, not here, you can say Scoop and help. You get this list of commands which are available. Out of this, we will take care of export and import, and we will also talk about create Hive table. You can go through the list of commands and understand what each one of those does. We will do a very quick hands-on on Scoop, and and we'll not dive very deep into any of these tools, but we will just do the things so that you all are comfortable to get into more and more details by yourself. All right, because if we try to focus only on Scoop or Flume, it will itself become a big course. Now, so Scoop connector is a basically a modular component. So today, as of today, almost every database which is relational database which has JDBC connectivity, meaning there is a Java driver for that, or which has a Java compliant driver available, a JDBC connectivity, Java database connectivity. There's a standard, there's a interface which is being implemented by almost all the database, which means you can connect to almost every database through Java, and hence through Scoop you can connect to any of these databases. Okay, so almost every database is already covered, but in case you have a newer database and you want to import the data from that, you can create your own connector. Let's try to do a very simple one from MySQL to to HDFS first. Okay, we'll try to do this using this. So in case your server is not running MySQL, first try to check that. Let's try to check if my command is running. What does this command do? It connects to MySQL. MySQL is a database. You connect to a database, create a database name inside it, which is like a namespace. Inside database, you create the tables and so on. Okay. Inside table, you keep your data. So here, let's see. It's saying enter the password, you press enter. So that means our MySQL is running fine. Inside MySQL, we can say show databases and semicolon. Now you can see that you see these all the database tables here. That means our MySQL is running. MySQL is again a database, and we are going to do is we are going to create dummy data inside MySQL, and then we copy that data to HDFS. Okay, so also please note that when Scoop will be connecting to MySQL, what actually will happen? Scoop will be running as a MapReduce job, and from all the four nodes, it might connect to the single database. Therefore, Therefore, you have to ensure on MySQL side that your MySQL can be connected from any other machines. You have to provide the permissions to other machines to connect to your database. Okay? Because by default, when you create a database in MySQL, it is not really available over the network. You have to give it a permission to make it possible over the network connectivity. All right, now here we have show databases. See that you can delete scoop 3. You can say drop database, and you can say scoop 3 one right now got deleted. Now let's create a fresh database. Now if you see list databases, show databases, and there is no scoop 3. Now let's create a fresh database, grant all the privilege to Hadoop 1, Hadoop 3, Hadoop 4, so that all the nodes can connect to it. Now if you are running in a virtual machine, then you will notice that these things will work fine. Okay, even if you don't give the privilege, everything will work fine, because there's a connectivity happening from local node to local node, and that is by default allowed in MySQL. Okay, and if you take the same script and try to do it over the network, it will fail badly, and you will be wondering that it was same script was running fine in the local mode, and what happened to my network mode. There's a connectivity failure all the time. That is because your scoop, any command you run on scoop will run as a MapReduce. Okay, which means that based on availability of the node will be selected. Not it might be Hadoop 1, Hadoop 2, Hadoop 3, or Hadoop 4. Okay, so let's try to give the privileges. We have already given the privileges. Now you can see show databases. You can see show databases, and There you'll see scoop 3. Good. Next is, let's try to create a dummy table. Here is the dummy table we are creating in MySQL, and it says the database is not selected, so we can say select, use scoop ex3, and then you do the copy paste. All right. Afterwards, we insert the data into this. See that? So these are the records which are in MySQL. Let's try to import them into HDFS. Okay, everybody with me? Right now we are in MySQL. We created a table called widgets. It has 3 rows and how many columns? 6 columns. Okay, we are trying to import it into HDFS. All right. Now let's try to import it. Okay. But before that, let's try to delete our table from our older data. Hadoop fs minus ls. Anuj, are you with me? And if there is a table called widgets, we can delete that, but there is no table called widgets. There is only widgets old. All right. Now, is everyone with me? What exactly am I trying to do? I'm trying to copy a data from MySQL into our HDFS using Scoop. Now here, what exactly I'm saying? So let me put the command line here. So I'm trying to say MySQL to HDFS. The first command I'm saying is this. It says Scoop import my data from here, from our MySQL to, and this particular to this, from this table to my HDFS. Okay, so let's have a look at it. Also, I'm providing a username called root, password empty, and number of maps as 1. Okay, my M1. So I'm telling that run it only on one node. That's all. Had our data been bigger, then it could have been easier to, it could have been more effective if you use multiple maps. Now you can see that even Scoop is running a MapReduce command to copy our data. Each mapper will be contacting the MySQL parallelly, copying and making the connection to MySQL and creating the file in HDFS. So if you have number of maps m minus m equals to 5, if you have number of maps equal to 5, then there will be 5 concurrent connection that might open in 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 our MySQL. All right. If you have 100 nodes, yeah, widgets is the table name. That's correct, Damodran. So that's what we are trying to do here. So if we are saying minus m100 here 100, that means, and you have 100 nodes parallelly on the data as data node or in the yarn cluster, what will happen is the 100 node might connect to your MySQL parallelly. Okay. So once you are done with this, it will create the file here in HDFS, and let's see if the file is there or not. We say Hadoop fs minus ls. You can see that the widgets folder has been created, and let me say, fs minus ls widgets, and here is the path. So this is where our data has been imported. Okay, we can say Hadoop fs minus cat, and then say you can see that our data is now in HDFS in a comma separated format. Sounds good to you? Alright, now let's take another case. Let's say now you have got this nice table in MySQL. You want to create a hive table. Okay, so if you remember what exactly we used to do for hive table, first, because in hive you have tables and the data is lying in HDFS, so what you do is generally you first create a table in hive, you connect to hive and say create table and blah blah blah, and then once you have created the table, what you do is load the data from HDFS into hive. Okay, that's what we are going to do. But if we are creating a table in hive and there is already and we are basically importing our data from MySQL to hive, right? So this definition has to be identical to what is there in MySQL, right? Because we have to create the data types, number of columns, and all, and so on. Okay, therefore instead of doing it manually, Scoop provides you a way to do it by a command called create hive table. So you can say things like scoop create hive table, connect to my database, create the table name called widgets, and my fields are terminated by comma, and username and password is this. Okay, so it has successfully created the hive table. Now if we connect to hive and we say show tables, then it will show us that there is a widgets table already. So we can say show tables, right? So there is a widgets table now. The table has been created from SQL to here. Now we can load data into this widgets table from our HDFS file called widgets. Okay, that means we are basically saying move the data from HDFS into this particular hive table. If you remember correctly, that is how we did earlier in case of hive. We create a table, then we load the data from HDFS or from local file system. Here we are loading the data from this thing from a HDFS file. Now you can see that the data has been copied, and I think we should say drop table, not drop table, delete from widgets. Select star from widgets. It's still there. Drop table widgets. Okay, and I will run this again. Okay, so now you can see select star from, sorry, show tables, there is a widgets table, and let's see if there is something in it. It will be empty. Now in this you can load the data now. Sounds good to everyone? Alright. Now that's what we did just now. Now there were three steps involved. First, we created our blank table in Hive. Then we loaded the data. Sorry, in first we uh, copied the data into HDFS, copied the data from MySQL to HDFS. Then we created a table in Hive, then loaded the data from the file which was created in step number 1 into the Hive table. So there were three steps involved. Now to do that in a single shot, a easier thing is this. You could do the same thing using a single shot. Okay. You can do the same thing using a single shot called scoop import and connect to this database, create this table, and mark. The only difference between our HDFS import and this one is this particular option. Alright, that's how we will be able to create, we'll be able to copy the data from MySQL to directly to Hive. Okay, you can see. Select star from widgets. Alright, alright, I think drop table. Alright, basically what we are trying to do is we are trying to copy a data from MySQL into Hive in a single shot. Let's just wait. I'm hoping it to finish. Sorry. So you can say select star from widgets. Now it's working. See that? It has been copied. Earlier, because we did not delete the table, that's why there were mistakes. You can see that. So we were able to successfully copy the data from MySQL to HDFS, MySQL to Hive. Alright. So this is done. These first two steps are done. Next is copy from MySQL to HBase. That's also pretty straightforward. Okay. So let's say you have a table called widgets in MySQL or any of other database, and you have a table called customer in HBase. In this customer table, you have a column family called CF1. Okay, and this is the username and password for the MySQL. So what exactly are we trying to do is we are copying these columns from this table into a column family. Okay. Now, if you recollect that in case of HBase, whenever we are trying to say that we are adding these columns, we always have to specify the column family, right? Therefore, when we are copying data from MySQL into a database, into an HBase, when we are copying the data from MySQL to HBase table, what will happen is we'll have to specify that these columns have to go in a particular column family. We always have to specify that, right? Therefore, whenever you're copying, therefore in this command, you will have to specify these options. Okay, you'll have to specify which table and which columns, which column family. All right, you can try that. All right. Next is that in case you have to copy the data from Hive into MySQL, the reverse of what we did in first step, it is very straightforward. First, you create a file in HBase, load that into Hive, and then you you basically copy that table back into into MySQL using this command. So I'll show you this. So let's say we go into Hive. Are you with me? So what exactly are we trying to do? We are trying to copy the data from Hive into MySQL. So all of these permutations and combinations are possible using these. Okay, you can see that. Let's say is there already a sales table? Select star from sales. So we already have created this table called sales. This contains these many records. We are trying to copy this into MySQL. Okay, so we go to MySQL. All right, we go to MySQL, and then there we have to create a table first. We have to create a table first. It says use default or use scoop ex3, and then we say we created the table. Now next step is to start copying the data from, let me also connect one more. All right, are you with me? Anuj, Arvind, Damodran, Srisha, Carl, Camp, Krupa, Praveen, Santosh, Savita, Subbareddy, Urs. Are you guys with me? All right. So you guys are in a sort of a listening mode. So keep asking questions. That way, I know that you are with me. And okay, if you have a doubt, what exactly am I trying to do? Because there are high chances that I might confuse you that whether this table is in Hive or this is in MySQL. Okay. So feel free to do that. Now on one hand we have MySQL where we have created the sales table, but this table right now does not have any data in it. You can see that there is no data in it. It says empty set. But on the other hand, here there is already a database table in Hive. So if you run Hive and say select star from sales.log, it will have the data. Now let's say we want to copy that from Hive into MySQL. So what are we going to do? We're going to run this command. So the terminology of whether it's export or import is based on the fact the where is the data located. Okay, so it's in reference to always HDFS. So when the data comes from MySQL to HDFS, it's called import. When we are taking the data from HDFS to MySQL, it's export. So everything is with reference to as if you are sitting on Hadoop. Alright, so here what you can do is you can run this command. So you can see what exactly I'm doing. I'm saying scoop export my data from this particular table in Hive. I mean, sorry, this particular directory, because if you remember, we discussed earlier that our tables in Hive are created in warehouse, and we can copy the data from a directory into scoop into MySQL using scoop. Okay, so the data has been copied. Now you can go back in MySQL and check, select star from my sales. So you can see that the data has been copied from our this HDFS directory to to our MySQL. All right. So if you have so we have covered all these cases where we have these 4 or 5 cases we have covered. All right. So you can try importing exporting just following the steps mentioned in this tutorial to clear the confusion. Trust me, once you do these steps, it will be far clearer to you instead of when you are just listening. Okay, so try doing it by yourself, trying running all the commands which we talked in Zookeeper. Try running all of this in case of scoop and these tools. So that will give you a far bigger confidence as compared to now. All right, try doing it. If you have a doubt, drop me an email. All right, good. So that was about scoop. uh, all right, now there is another tool called Flume. Flume is really useful when Flume is not like our usual import export tool. Flume is a data pushing engine. It pushes data from all nodes onto our HDFS. Let's take a case scenario. Say, let's say you are running Flipkart, or you are running any service which needs to run your web server on 10 or 15 different nodes. All these nodes are generating the data continuously. Let's say they're generating the logs, they're generating the history of all the URLs accessed from these 15-20 nodes. Okay, all these nodes are generating the logs of who visited the website. Now, this is happening at a very fast rate. And what you want is you want all of this data to be pushed continuously into the HDFS. So for doing that, you'll have to use Flume, and it's quite useful. And in concrete terms, it's a distributed, reliable, and available system for efficiently collecting and aggregating and moving data from many different sources into a central data source. And the central data source is mostly HDFS. Okay, so you can gather the data from multiple sources onto one. So let me answer them. So Damodaran, scoop is basically data exporter or importer. Okay. From slash to, okay, I think it'll be like this: RDBMS in and out our Hadoop. This is what it is. All right. That's what we did, right? Copy the data from SDFS and all. Now here in Flume, what we're trying to do is we are trying to copy the data from many sources onto a central one. And this is very useful when there is a continuous data coming in from many different sources. Okay. Now, the architecture of Flume is very clean and very generic. Okay. Just like a connector, we had, I think a better diagram would be this one. I create a diagram. I just did not put it in this. Yeah. This is what I had done earlier. So let me try to put it here and that will be more sensible. All right. So we have, all right. So the Flume is made up of these components. All right. So I think this will make the architecture really clean and very obvious. All right. So what exactly is Flume? Flume is for collecting data from various sources at a very fast pace onto a central system like HDFS. Okay. So a Flume is made up of a lot of agents, and these agents, each agent is running on all the nodes from where the data is being collected. Okay, Each agent looks like this. Each agent has got two parts. One part is called source, other part is called sink. Okay, similar to your USB cable. On one part you have a USB 2.0 connector, which is sort of female. This part section is a male section, which is micro USB. So the data from this side comes in and goes to the sink side. This is source and this is sink, meaning this connects to sink and this is the source. Okay, now you have never used multiple source and sink in conjunction. Okay, a sink can be connected to another source, although this diagram makes you feel that a sink cannot connect to source, but it can be. Okay, a sink can connect to another source like this. See that? All right. So what's happening here is there are multiple agents. First agent, second agent, this agent is sending data to here. Similarly, one sink can give the output to multiple agents, thereby transmitting data. Similarly, one source can consume data from two different sinks and thereby transmit data from one place to another in a very effective manner. Make sense to you? What are we talking about? So on each machine, it is important to transmit data, and say you have to consume data from XML and save it as binary or save it as something else. So you can basically back to back connect them and convert from one form to another. Okay. So that's what a flume is. Is everyone with me? What am I talking about? No? Where does the flume sits in the network? Good, good. So good question. So let me just write it here. So on each node where the data is being generated. So flume is basically a collection of something called flume agents. Each flume agent generally runs on every node which is generating the data, and these nodes are transmitting data to HDFS by this. So each agent or each node is this one, and this one. This one contains three nodes, this one contains two nodes. Okay, and that's what it is. Let's try to build it. Let's try to build the Flume network right now. Okay, how will we build? So this side is called source, this side is called source, and this side is called sink. And there is a channel. And why do we require channel? Say source is generating data at a faster pace than sink can consume, then the data can lie in the channel in the midway. Okay? In case in case sink is consuming faster than the source, then this pipe will be freer. Okay, therefore this channel acts like a buffer for the difference in the rates of consumption and production, and thereby it helps in doing the parallel activity. While at one end let the source generate the data into the channel, on other end let sink take its own sweet time to consume the data from the channel. Okay, that's why the Flume architecture is very important in this way. Okay, so Flume supports a variety of sources including tail, syslog, and log4j. Flume nodes can be arranged in arbitrary topologies. Okay, Flume nodes can be arranged the way we have just now showed you. There were two topologies in which one agent is connected to another agent, and here one agent is connected to another agent which is connected to some other agent here. So there are four nodes: one, two, three, four. I counted three earlier. Now the other question is, say Amazon has 10 proxy web service, 10 cities, and Amazon HDFS sits in HDFS. Can you explain with an example? All right, let me try to, good question. Let me try to answer this. All right. So let's say Amazon has hosted 10 proxy web server, 10 cities, and sits in Delhi. Doesn't matter anyway. So basically, we will install Flume agent on all 10 web servers. Okay, on 10 web server we will be installing the 10 agents on our cluster, and these agents will specify that push our data to HDFS, and parallelly all of these nodes will be connecting to HDFS and pushing the data. All right, next question from, okay, now next question from Damodran is that how is the compression handled? It's a proprietary form of web data is made in, yeah, so it is generally kept in binary data. There is a standard binary byte array kind of a data. Okay, I'll show you that, in which it is kept, that format. It's not compressed, but you can compress it. You can have different kind of channels to compress the data. All right, or do you have different kinds of sinks which basically do various kinds of job. Okay, like compression job could be one sink, and you can connect these. All right, now let's say how to create an agent can be composed of many different kind of sinks and many different kind of sources could be things like tail, syslog, log4j, so that sources could be any log mechanism or any data productions. All right, let's say in this case, if you have a look at this, or yeah, if you have a look at this, what's happening here? All right, this is not correct. Okay, all right, let me also go to the terminal. Here it is available in as Giri and Flume. Okay, so the description of agent, as in this agent's composition, as in who does it connect to, what are their sources, all of it is inside this config file, and when we launch the Flume agent, we will specify this configuration file and launch the agent. Okay, so let's go into conf and have a look at Flume dot, I say vi. You can, if you don't like vi, you could also use nano Flume dot properties. You can press tab to autocomplete. Here, what am I saying is, I'm saying the agent name is A1. A1 dot sources are only one, which is with the name R1. A1 has got one sink called this name, and A1 has got one channel called C1. Okay, now let's describe R1, C1, and this. R1 dot type is netcat, R1 dot bind is localhost, and R1 dot port is this. Okay, so I'm saying that my source is R1 and R1's definition is netcat. Basically, what is netcat? Netcat is sort of a server which can listen on a particular port so that other services can dump the data on that particular port, and it can consume that and put it on HDFS. Okay, so we are going to start our source is going to be running at this port on localhost, and our our final target is to take the data into this sink. Our sink's definition is that it's a HDFS and at this location. Okay, let's open this location on the web. All right, let's try to open this location here, and we say Hadoop 8000 slash this data. So what are we going to do is we are going to start we are going to start a service which will listen on a particular port, and whatever we data we give it to it, it will put it in this folder. All right, let's delete whatever is there. So this HDFS folder is now empty. Okay, now we will run our agent, and then we'll give agent some data, and then it will start pushing that into HDFS. Now let's take a look at it. Okay, so we defined this configuration file. It says that our source is netcat. Netcat means listen on a particular port for the data. Okay, and here we are saying our channel is in memory, meaning whatever data we are pushing, it is kept in the RAM. Let's start it. Let's start our agent. Go back a bit. So it's launching the our Flume agent. Now Flume agent has been started. It says that it's listening on this particular port. Okay, now to talk to our Flume agent which we have just launched, we can say telnet localhost, and what was the port? 4444, right? And one more 4. It says that it is now connected. Now we can keep on typing the data here, which means we are connecting to our netcat server, which our agent, we are right now talking to our agent, whatever agent we have started, by the way of telnet. Telnet is a client which can connect to any network service. Okay, not only SSH or anything. So we are pushing this data, and parallelly this data is being pushed here. We can refresh it and see the data. You can see that it shows whatever we have typed here is being written here, and the data is in the format of binary, and this binary format is defined by this class called bytes writable. Okay, so that way we were able to successfully run agent which was listening on a particular port for the data. It is like a network service who is listening for data, and anybody who comes and tries to write to it, it will push that into HDFS. So Damodaran's question is this some kind of YAML file? It's not YAML really, but it's basically a very simple config file. Config meaning it's basically key value pairs. Okay. Most of the Java property file, Java configurations are in key equals to value kind of format. In case of YAML, the configuration can be hierarchy, okay, in which you separate out the blocks by tabs. You define your blocks based on the tabs. All right. Kind of, yes. All right. So I hope the Flume demo was useful for you. No? All right. So we were able to generate data and got it pushed to the server. Okay. Now, how are the channels implemented? Good question from us. Here, here the channel which we are talking about are in memory. There are many different kind of channels which are there. One is in the disk, other could be into some other format. Okay. So right now we are only having. Okay. So there are many different kind of channels which you can define here. Right now we are only talking about in memory. It's like channels are implemented like a queue. Okay. Channels are implemented like a queue. Okay. Like a queue could be in memory or on disk. Does that answer your question, Urs? And next question is, what happens if there are 101 transaction requests? How is the flow control happen from backend to the user interface? I did not get this. So what happens if there are 101 transaction request? Okay, good. So transaction capacity is 100, right? Or let's say, let's talk about the capacity first. What happens? All right, good question. Very good question. Now, coming back to here, what happens when, so you start putting data, the channel is getting filled, okay? And the source is producing data at a faster rate than channel can consume, okay? Or the channel being consumed by sync. So data is being accumulated in the channel. If that continues, if the data keeps gathering in the channel, what would happen is channel will overflow, right? At that point of time, the source will stop generating the data. Okay, when the channel is full, source will not accept the data and skip the data as much as possible. Okay, similarly, in case channel is empty, then sync will stop performing. Sync will not do the job if channel is empty. Make sense, Damodran? Or you can have a understanding like this. So in case this channel is full, then the source will stop accepting the data, and hence the sync will stop, and then channel will stop and source will stop. Okay, so this channel can stop the process in the game. So good, very good. So Anul's question is it similar to producer consumer? Exactly. So most of the producer consumers are actually emulated by a pipeline. And that's exactly how an agent is defined. So to solve any producer consumer problem effectively, the this kind of a channel and queue is the solution. Good. So Damodaran, was I able to answer your question? And Anuj and Urs, how are the channels implemented? No? Okay. Please email, or you can ask if you have. You can ask. All right. So I'm moving ahead. So this was our quick demo of Flume. In the similar manner, you can basically form all kind of combinations of source and sinks by mentioning them in the config. Okay. All right. Now comes another thing called Uzi, and I think when we talk about Mahat, and I think we should come back to Uzi after that. All right, we'll come back to Uzi after we discuss other topics, because I think it's better to discuss Uzi after we have discussed Mahat. Okay, we will change this order later on. So, although Mahat is partially obsoleted by other newer libraries like MLlib, but still Mahat is fairly useful for any beginner in case of machine learning. Okay, Mahat is still very relevant. They are rewriting most of the machine learning library, but still Mahat is fairly important when it comes to machine learning in big data. So NGETL wrote a paper called MapReduce for Machine Learning on Multicore, and that paper became the basis for Mahat. And soon enough, it became the top level project in Apache in April 2010. In Mahat comes from a Hindi word, and it means a person who keeps or drives an elephant. Okay? He sits on elephant and controls it. So Mahat is basically a collection of algorithms. It's a library of algorithm for various kinds of machine learning work. Okay. Now, what exactly is machine learning? Machine learning is basically programming computers to optimize a performance. So when you see a problem, you look at the input data, you look at various solutions provided by various people in those circumstances, and then based on a newer problem, you try to form the newer solution. Okay? So basically, in case of machine learning, instead of human doing the prediction part, instead of human saying that for this input these are the kind of output I have seen in past, okay, instead of that it is the machine who does that prediction part. Okay, and it's a branch of artificial intelligence, and and the design and development of complex algorithm happen through the machine learning. Let's say we talk about face detection, whether something is matching with my face or not. Okay, one way would be that somebody sits down and write an algorithm, measures my distances between eyes, the distance between eyes and nose, and then somebody writes a program that, okay, based on the eye distances between eyes and nose, it's Sandeep Giri's face. Okay. Now, but in case of machine learning, we give the algorithm lots and lots of data and tell him that this is Sandeep Giri, this is Damodran, and this is Anuj, and on and so on. Okay, we give all of these millions of records to the algorithm, and algorithm automatically figures out and correlates. Okay, I'll give you a good demo, probably that will be fun today. So Anu's question is it part of data mining? Is it part of data mining? So data mining is just one use case. Data mining is just one use case of machine learning. Machine learning can be used in number of places. The first place you had seen machine learning in place for quite some time is Amazon's recommendations. Okay, I will show you a good demo of machine learning right away. You'll feel good about it. Okay, so are you ready? Here we go. All right, here I'm going to say Mario and Mario machine learning. All right, here we go. So in this example, what this guy had done is he programmed. So how many of you have actually you played a game called Mario? Have you played a game called Mario in your childhood? Anuj did. Good. Damodran did. Arvind hasn't. Srisha has not played. Arvind has. Super Reddy has not played. Who else has played a Mario in childhood? This one, I think this diagram will show you what exactly are we talking about. You remember this game? Great, great. So, I mean, the way a child learns to play. So, Damodran, you can connect because you have your son playing this game. The way your son automatically learned playing the game, in the same way, this person coded this person coded the machine learning algorithm to basically keep an eye on the score, keep an eye on the score, and now look at this. This is he playing, as in this researcher is playing the game. This is doing playing pretty good, but then in the beginning, let me. All right, now let's have a look at it. Now look at this. In the beginning, when he coded the algorithm such that it will observe the game's memory and also observes the score. Okay. Now the computer is getting the feedback immediately whether its score is increasing or not. And based on that, it is figuring out that what results in the score increment is trying to learn automatically playing this game by observing the score. Okay, so there is input data, a lot of input data from the memory of this game, and and the output is corresponding to the game score. Okay, now you see, initially the computer is playing very stupid. It's not doing anything. It's just jumping around. It's not moving at all. Now it's slowly starting to move and figure out that okay, fine. If and this is a result of maybe a day of playing. Okay, now it is stuck at jumping at this point, and then stuck forever. Now it has started playing a little better after some time by observing that things are going good, and then you can see that it has figured out if it jumps on the Goomba, it will basically on the score is increasing because it's jumping on that Goomba. Okay, also you see that this time it is stuck here, but then it figured out that if it jumps better, it will be able to score higher. Now the it's a computer playing the game, and nobody coded the computer. Computer learned playing this game by itself. The researcher, this guy, only thing he did was it told the computer that this is how you press the keys, this is how you see the score, and your objective is to increase the score as much as possible. Now, after a couple of weeks, this is what it is doing. At this point, it will get stuck here and die. Okay, and then we'll try to, in the next life, it will try to use that knowledge to crack it. Okay, now you see, after a couple of days more, now the computer is starting to play really well. Now look at this game now. See that? It's playing extremely fast. Look at that. Look at that. So it's playing extremely fast and extremely well. You can see that? Now for some reason it has jumped here. Basically it has figured out that falling is useful because it gets the next life and do a better job. See that? Now see one more important. See, look at this. So it has actually killed a Goomba even though Goomba was jumping on it. So what exactly did he do? He found a bug in the game and exploited it. So a software could find the bug in the game and exploited it. So he not only so the benefit of machine learning was that he did not have to code all of this. Instead, computer learned by itself. Also, it not only was useful in one game, but almost every game it played better than the human. Okay, therefore, a machine learning algorithm is is really powerful, is really useful when it comes to the next generation of computing. And why do we talk about this now is because machine learning algorithms are only useful if you have enough data. This thing what we just saw in case of Mario, the program learned all of this in a week's time. It had to continuously play for a week, and it learned all of this in a week's time, not in like 10 minutes or 20 minutes. No, it kept on playing 24 by 7, kept on failing so many times, and then reached to this level by trying and learning automatically. Sounds good? I'll give you this video's link. So does it sound good to you? Was I able to explain what it was about? No? Yes. So, Damodaran, these days, these algorithms and this machine learning has become really marvelous, and most of the face recognition, voice recognition, everything is being done really well. All right. Earlier, people were coding it. People were very scared of this AI, but now it's very well controllable. Okay. So this is how computers evolved behavior based on empirical data. Why empirical in this case? Computer doesn't understand whether there is a person looking like Mario or what is the graphical color. It doesn't understand that. It all understood was pressing these keys resulted in this and that, and based on that it forms a mathematical correlation that that jumping on this increases my score, and doing this way increase my score, and that's all. So this is empirical data based on which the whole intelligence was developed. Yes. So the machine learning itself is like a very vast area, and it's not a result of one person's work. These algorithms are open source, public, and are a result of probably 50 years or maybe 70 years of research from the industry. Okay, these kind of algorithms people have been working since 1960s, and right now they are able to reach to this level that they are very powerful. All right. So, I mean, Damodaran, the first machine learning software you can play around with would be your this Mahout. Okay. And also this game which I've showed you just now, the source code is available in public domain. You can try it out. If you have Visual Studio, you can try out the game I've just showed you. Now, okay. Now, there are various kinds of machine learning. One is supervised, where these are labeled training data, and we basically say that this is good email, this is spam email, this is bad email. Okay. So basically, we know that what is good and what is bad, and then we give that data to algorithm understands that, and then it starts the prediction, or it starts classifying. Take a case of your email. In your email, when your emails are coming to your inbox, Gmail automatically categorizes them into spam and not spam, right? Now, initially, if you have to write a spam filter, you will have to train it. You have to tell initially, maybe for 10,000 emails, that this is spam and this is not spam, and so on. Okay, this kind of learning is called supervised learning. Then there is something called unsupervised learning, which is given a lot of data and we tell the computer that classify it, please. Okay, we don't tell it that you know this is my input, this is right good output, this is my input, this is another we don't do that. We do not provide the labels. Instead we tell the data, we give it full data, and then tell it to categorize it. For example, giving the let's say we give the whole list of species of the world to the computer. We tell that this is human, humans weigh this much, humans eat this much, humans have 2 ears, and so on. Similarly, we give the characteristic of the whole lot of species. Okay, and then we tell the computer that please create a hierarchy tree out of it, saying please create a hierarchy tree out of it such that two nodes which are children of the same parent are very close to each other. Okay, that is called unsupervised learning, the kind of thing which Darwin did based on the behavior of the all species. He tried to form a hierarchy of species, saying humans and monkeys are similar to each other, therefore they are the children of the same parent, and so on. So this kind of job where the computer is supposed to predict the predict the hierarchy or predict the groups is called unsupervised learning. For example, giving given all the email IDs of the sorry, given all the news articles from all news sources, automatically cluster group the data into 10 buckets. Okay, given all the email IDs of the world, sorry, given all the newsletters from news articles from the world, please classify them into 10 buckets. So this is called unsupervised learning. In certain cases, your semi-super there is you are in between. In those cases, you are it is called semi-supervised learning, where the data has to be classified automatically, as well as you have to specify some amount of information. Okay, those cases are called supervised learning. So Damodaran, these are the another use cases you can look at. So the recommendation was the first example of machine learning. Recommendation was in many forms. One was the Amazon one, where we say that since you like this product, you will also like these products. Similarly, recommending friends that you may also like to connect with these people. Recommending dates, recommending products to end user, classifying content based on predefined groups. These are all machine learning applications. Finding similar content based on object properties, and then identifying the keywords based on your full article. You have an article, automatically figuring out what does this article relate to is called is called so for example, I'll show you wit.ai. You can see that. So there are these artificial intelligence library which can convert the normal text into some sort of sensible information, like this: remind me to feed the baby tomorrow at 7 a.m. It automatically converts it into this kind of information. If you are looking to convert these kind of thing, you can start using the wit.ai kind of library. Okay, so there are many natural language converters which are available as of today, and they give you a lot of detailed information. Not only this, but also things like things like uh, I mean things like predicting various kinds of sentiment analysis and a lot of other behavior. So identifying key topics from a large text, detecting anomaly, ranking the search results based on user feedback learning, classifying DNA sequences, all of this could be done using machine learning. Okay? Computer vision, identifying faces, figuring out faces, whether something is an object or not. Natural language processing, which I just demonstrated to you, and then biometric, speech and handwriting recognition. The specifically those problems where people have not been able to form the algorithm really well. In those cases, these the machine learning algorithms are doing far better than the people. Okay, so therefore, so that's a kind of use of machine learning in normal life. All right. When it comes to various tools in case of machine learning, these are the wide variety of the tools. There are many more tools, but I'll try to keep it very simple. So when you have few lines of data, so the easiest machine learning was the prediction of the next number by plotting the graph, right? If you remember, if when we had these graph problems, so what we did was we were given like few records. Okay, last year our sales was this year our sales was this year, and next year probably our sales are going to be like this. Okay, so you basically, or let's say we have 10 years of data. Okay, and let me just try to be a little more, yeah. So let's say we have, say, 15 years of data, and ouch, it doesn't have a pattern. So let's say we have this past few years of data. So the easiest way is you draw a line from one place to another, from here to here, and then you draw a straight line, and then based on that you start doing the prediction. The next year this will be my result. Okay, these are of my past year. This is 2014, this is 2013, this is 2012, this is 2011, and so on. So our production was this much in 2001, 2002, and so on. Based on this data, what we have done is simply drawn a straight line which is closest to all of these points, and then said that next year this is going to be our production based on our past experience. This is the easiest form of machine learning. Okay, we just plotted a graph and did the prediction. So this is the easiest form of predictions. If you have few records, you can draw such a line on the whiteboard and start doing the prediction. You don't require any other tool other than a whiteboard. If your data grows into a little more than few lines, then you go with a tool like Microsoft Excel and try to do the predictions. Okay, in case your data grows into few kbs, if your data grows into few kbs, then you move to tools like MATLAB, R, and Octave, or maybe up to MBs of data, which can then you can use these tools. Okay, why? Because these tools are not suitable for bigger data. Reason being, most of these tools are being used, so are most of these tools utilize only the RAM. They don't have multiple computer, or they don't utilize the other ways. But if your data grows into lower GBs, as in 1 GB, 2 GB data, then you can use NumPy, SciPy, and in those cases the visualization and analysis tools become different. Okay, and in case your data goes into terabytes, then you go for Mahout, Giraffe, and MLlib kind of libraries. Okay, so these are the various kinds of libraries, and the example which we will cover tomorrow is this one. We'll try to do a of prediction of movie recommendation based on the past data. So, for example, Sandeep likes Matrix, Sandeep likes Casablanca, Kumar likes Matrix and Kumar likes Shawshank Redemption, and this much. So Mahat will, based on this three-column data, Mahat will generate the movie recommendation saying Kumar might like Casablanca, Sandeep might like Shawshank Redemption. It could be based on understanding of the user attributes, such as these two users are closer to each other because their movie likings are similar, and so on. Okay, we'll take up this example tomorrow. All right, and that's, I think, good enough for today. All right, we'll take up Mahat, and then we'll take up Uzi, and then we will continue with Spark, and that will be good enough. All right, thank you very much. Have a great day ahead. All right, great. Thank you. I'm happy that you found the session nice. And yes, so Anuj, what number can I give you a call on? All right. So you are located outside India. All right. All right. So don't I have to type +1? Okay. All right. Thank you very much. Have a great day. And Anuj, I'll give you a call. Thank you, Anuj. Thank you, Arvind. Thank you, Damojan. Thank you, Srisha. Thank you, Carl. Thank you, Kirupa. Thank you, Praveen. Thank you, Santosh. Thank you, Savita. Bye bye. Have a great day ahead.